So, welcome everyone. My name is Jacob Flickel. I'm Director of Sustainability Operations and the Sustainability Office here in Northeastern. I sit in the planning, real estate, and here. And, we have a small team here working on help trying to integrate sustainability within everything we do here. And today, wanted to introduce you and hear from some of my colleague Juan Gil Figueroa, who's a well, sorry, what's your I'll let you introduce yourself. I know you have a new title, but he'll talk about a project he worked on that most of you in the Boston campus will know about, Whitehall demolition and everything involved with that, and also Nancy Varney, professor over at College of Engineering, to give us a really good overview of building deconstruction robotic. So I think here at Northeastern, one thing I've been trying to work on is to integrate some of these concepts and ideas within our construction projects. A lot of them are new. A lot of them are kind of different with how things are normally done. But now is the time to try to figure out what we can do and maximize those opportunities. We'll leave some time for questions at the end. And you can feel free to follow up with me afterwards too if you have any questions or continue this conversation. So without further ado, I will turn it over to Nancy. Please introduce yourself and give us a great introduction into deconstruction.
Sure. Thank you, Jacob. So I'll just introduce myself real quick. So my picture shows a little bigger before I show a few slides. So I am an associate teaching professor here at Northeastern in the College of Engineering. My area of expertise is in structural engineering. And in fact, I worked in the industry for 10 years before coming back to Northeastern to teach. So what I plan to do today is just give you a kind of a general overview in terms of, oh, Jacob, can you give me permission to share, please? A general overview in terms of sustainability when it comes to building structures, with a little bit of an emphasis more on the structure itself, the concrete, the steel, the brick masonry, because that is more of my familiarity. And then Juan can give us what you're really here for, learning more about what's happening on campus. So with that, let's see if I can get my slides to go. Oh no, it's always the trick of which screen it wants to show things on. All right, let's try that. Do you see my full slides now?
We see your slides, but you can yes.
Okay. So with that, a little bit about sustainability. Most people, when they hear that term, think of the environmental side in terms of environmental justice, natural resources, but we need to make sure that we're balancing everything, not only the environmental, but also the social in terms of standard of living, education, community. So really thinking about our buildings, our campus in the sense of community, and also economics. Like we have to make sure we're making decisions in terms of costs and money, as well as the carbon, the environmental side of things. So that we always need to keep in mind that sustainable development, when we're thinking even building new buildings on campus, is making sure we're meeting our present needs without compromising the future generations and their needs as well. One of the big things that we're seeing is we have this rapid growth with new construction. Just some of the numbers that they're throwing out are kind of wild, but just throughout the building floor, when you think about like office buildings, apartments, everything like that, it's expectable by 2060. So these numbers are a little bit, but still pretty relevant. It's the equivalent of adding an entire New York City to the world every month for the next 40 years. And thinking about that, 3/4 of the infrastructure that we have or that will exist in 2050 has yet to be built. So that's a lot of construction, a lot of materials, kind of both costs in terms of money and carbon going out into the world. So trying smart decisions as we go through this. When we hear about carbon emissions, so CO2, we're going to be kind of group all of the greenhouse gases to an equivalent carbon emission. Most people think of transportation. Like we're making great strides in better green energy in terms of our transportation, but the built environment, our buildings that we live in, that we work in, actually contribute a large amount, approximately 40% of the annual global CO2 emissions. 27% of these are from our building operations, heating, cooling, electricity, everything that we use in our day-to-day lives. And about the rest of it is what we call embodied carbon, essentially what's locked into the building from day one. And a lot of this is in our four major structural materials: cement, steel, and iron, and aluminum. But also masonry, all those other pieces that if we can try to reuse it will help make great strides in creating a greener built environment. We have a lot of organizations that's focusing on making sure we're reducing carbon in our built environment. Architect 2030, MEP 2040, and SE for the structural engineers 2050 are all targeting different ways, both on the operations side and on the embodied carbon side, to make structures greener. So just highlighting embodied carbon, because that's what we're going to be focusing on today in terms of what's locked into our buildings and what we're going to try to save when we're going through deconstruction projects. Our carbon emissions, so all of our greenhouse gases kind of equated back to CO2 that are associated with building or infrastructure projects and the actual construction of them too. So it's everything from raw material extraction, digging out the iron ore, mining the limestone for concrete, the manufacturing and the transportation of these items through each step in its life, including construction, through the end of the life, either disposal or recycling. Recycling is key, kind of keeping everything in this whole circular economy, but to the extent that we can as an already fabricated piece. So like I said, once it's locked in and constructed, it's not carbon that can be taken back or reduced. It's built into the structure. So we see that the majority of our carbon emissions is really locked into new building infrastructure projects. So we're continuing to improve operational efficiency through better insulation, more efficient HVAC systems. But what we really need to work on now is improving embodied carbon. So kind of breaking this out into some more Carbon Leadership Forum cartoons, really we're looking at embodied carbon, materials extraction, manufacturing, transportation, all of that is built into this embodied carbon slice of the pie. As we continue to make operational energy more efficient in terms of our lighting, ventilation, water heating, cooking, all of that, we can see that slice decrease, but our embodied energy becomes a bigger portion of it. So now that's our kind of next challenge to tackle. You may have heard a lot about carbon offsets in terms of our renewable energy production and carbon sequestering, which helps reduce the total net carbon impact, but we need to attack it from all fronts. One solution alone isn't enough. Focusing on the structure itself, MEP and other make up like finishes and things like that are a smaller slice of the pie when we're looking at the embodied carbon of a structure. And I found this old photo of the Prudential Center under construction, which I thought was pretty awesome just to see how empty it is around, but it just shows the skeleton and the beginnings of the enclosure going up. But if we're thinking about everything that we're seeing in this photo right now, the structure is 40 to 50% of the total embodied carbon locked into that building from day one, and the enclosure is another 20 to 30%. So a lot of carbon already going into every structure from the very beginning before we even turn the lights on. As we go through planning any of our projects, whether it's on campus, in Boston, in the greater global area, we need to consider what we can do, and the sooner we make good decisions, the bigger impact it can have. The easiest thing is to say to build nothing. In that case, we're not spending any carbon, we're being very green, but we need to see if that really satisfies our needs. A lot of times we're building things because we're growing, we're expanding. So can potentially build less or make use of things that are existing already, reinforce bridges, expand buildings, or be clever about our designs or build more efficiently. Each one of these has a decreasing amount of carbon reduction potential. Building none reduces 100% of the carbon because you're not doing anything. But it also means you need to start at a different stage in the whole construction process. Planning, design, construction is the sooner that we can start thinking about these things, maybe reusing existing structural elements or finishes or refrigerators or whatever you have, the bigger impact that we can have. So early stage design decisions are key. And also with that, we can kind of see what else we can do along the lines. So one way to kind of assess an entire project is to develop a life cycle assessment, to take a look at what's happening from stage one, raw materials, through construction, maintenance and use, and the entire end of life of a building. So this gathers information from raw material all the way to where it's returned to the earth. The best thing we can do is keep all of our existing structures going. But there have been issues with, let's say, structural compromises, or it's just not a particularly useful program anymore. We can find ways to take pieces out of those structures and reuse them in new structures to help keep this cycle going. So our goal is really eventually to achieve zero embodied emissions. So this whole reuse, reduce, or sequester is kind of adopting the principles of renovating existing buildings, reusing recycled materials, or even better, reusing materials as they are. We don't have to melt down steel beams if we can use them with kind of pick them out of one building and put them in another. Or this idea of designing for deconstruction. We can deconstruct a building, reconstruct it somewhere else in a slightly different configuration to kind of keep that use going. In terms of materials, we are using new construction, making sure we're using the right type of materials for the right uses and optimizing the sizes and everything, and specifying low to zero carbon materials to help decrease the overall impact. And then sequestering is our third step, which is just trying to use materials, find sources, ways of pulling carbon dioxide out of the air and storing in some use or another. A big way of doing this now that people like to talk about is just using mass timber, using trees naturally to sequester carbon and lock them into our structures. What we're focusing on now is kind of what we're doing with our existing buildings that are no longer meeting the use that we need them for. We have to kind of weigh all of our options and decide what's the best course of action, because even demolition alone has a huge environmental cost. Unfortunately, our culture kind of prioritizes tearing down structures instead of reusing them, retrofitting them. We're kind of liking to be in the most fashionable, not only with our clothing, but our structures as well. So kind of changing that mindset is a slowly evolving process. We can find that as we start to recover and recycle a lot of our materials, we can make a bigger impact. But this consumes additional energy because it's a more slow process. You have to be careful about not accidentally damaging the structure as you're taking it apart. It's pretty complex. It takes a lot of time. And for now, it only has a minor impact. We need to kind of move this forward and see how we can reuse a lot of our structural members, our architectural finishes, our appliances, everything in existing buildings, and find new homes for them. So on the other side, instead of just completely demolishing a building, is trying to use these materials, diverting them from potential waste streams, at keeping them out of the landfill to reduce the consumption of new material, and even maybe contribute to aesthetics of new construction. If you can incorporate something old, something cool looking, and really appreciate where it came from. I guess I'm not an architect, so I can't speak to that too much, but I love seeing exposed structure. So that always makes me excited, even if I know that it came from somewhere else. So when we're talking about salvaging as opposed to recycling, salvaging is reusing an existing item with minimal processing. So we're not melting anything back down. We're not bringing it back down to a raw material. We're essentially cleaning it up, maybe adding some new bolt holes or something so we can reuse it, trim it to size, but we're not putting in as much energy as recreating the entire system. Recycling, on the other hand, is actually destruction of a used system, melting it all the way back down so that it can be manufactured into a new product. So again, when we're thinking about deconstruction, we need to be careful. It's the careful disassembly, salvage as many components as possible. So you can't really come in with a wrecking ball and start taking out the building. You need to kind of take a more slow and costly approach. So some of our structural design considerations that we take into account are what materials work well. So brick, steel, and wood usually can be taken out of one structure and put into another. Concrete is often what we call downcycled because it can become contaminated through road salts and other issues, oils, things like that. So a lot of times we'll crush it up and use it as a base. It's not often remixed into new concrete mixtures. Something that we need to make sure we understand, at least on the structural engineering things, is knowing where our materials come from, giving clues to their structural properties. We didn't know how strong our materials are, if we're able to weld to them. So the photo that I'm showing here is an example of a riveted steel beam and column system. Essentially, we wouldn't not necessarily trust this steel to be weldable, so we have to take special precautions when we start to try to strengthen it or attach new members or things like that. And also durability, that's going to be key. Has there been any issues with corrosion or rotting wood or kind of concrete spalling that we even need to consider if we're starting to reuse members? So some of our challenges, let's say you have this great old building, it's got some good bones, if you will, but we want to make sure we understand all of our challenges before we start to take it apart. One would be going through our material testing to understand the properties so we know what we're able to use in any future designs. Considering any issues with contamination. So for example, if we're pulling apart trusses out of Matthews, for example, is it painted with lead? Do we need to go through and de-lead all of the structural members, all the truss pieces before we can reuse it? If we're pulling apart this great old wood structure, do we have to worry about nails? Are there any issues with damage in terms of wood rot or insects or anything like that? Do we have chlorides in our concrete? So those are all cases where we need to go through and examine everything, but it's tough in an existing structure because a lot of the structure itself, those bones, if you will, are hidden. So making sure we understand contamination and damage, either existing or as we start to deconstruct things, if will cause any issues. So kind of being more careful with what we're doing. So the photos I show on the right are from a Walter P. Moore presentation where they deconstructed part of an old stadium down in Georgia to salvage some steel elements to reuse in a reconstruction of part of that stadium. But part of it involved carefully taking concrete deck of composite steel beams, which is time consuming. So thinking about those logistics in terms of the cost and schedule. And the planning, and also, do we have place to stockpile these before these structural elements, refrigerators, finishes, light fixtures, whatever you have before they're able to go into their new home? And also how easy it is to deconstruct things. This idea of design for deconstruction is relatively new. So any of the buildings that we're going out and kind of taking apart now weren't really put together with that thought that it would eventually be carefully disassembled. So kind of just leaving you with one idea is this whole sustainable stewardship, that buildings are vast repositories of energy because of everything that has gone into them already, from the raw materials to the manufacturing, construction, even from day one. And all that energy is embodied already in the finished structure. And if we demolish it and throw it away, everything that was locked up in there is totally wasted. So we want to make sure we can find ways to bring all that back into any new structures and kind of keep this circular economy, if you will, going. And that's pretty much what I have. It's a rough, quick introduction to structural sustainability in a nutshell, but I guess with that, Juan, can I
You can kick it over, it's fine.
kick it over to you?
Actually,
So, unshare.
Juan, if you don't mind, I think since maybe keeping it at Nancy, any questions you might have for your so Nancy, thank you very much. That was a really great overview um, of the of what's what's embodied in a building. Would anybody have any questions right now, just for Nancy? We can always ask them later, but anything come to mind for folks?
I have a question. You referred back to being able to sequester, I think that's the word you used, sequester uh, carbon in the materials. How do you kind of figure that, particularly when you're talking about cross-laminated timber? How does that figure into the modeling?
So when we're working with timber in particular, we work closely with forestry experts, kind of with the idea that if you let a forest grow, the trees are gonna continue to sequester carbon throughout their lifespan. But if they were to naturally die and rot or burn, that carbon gets re-released into the atmosphere. So through sustainable forestry, we can actually cut down the trees when they reach a certain life. Essentially, they're not sequestering as much carbon as they when they're younger. Find a way to kind of quantify that as we bring it into our buildings and think of that as a way to lock it in. Essentially, it's not going to burn, hopefully. It's not going to rot. And so with that, we can go in and replant new trees to continue the process going. Like a jagged curve in terms of like what we're pulling out of the atmosphere. But it's one way to sequester carbon. I know there's a lot of startups that are looking at high-tech scientific techniques to try to kind of solidify carbon or inject it down into the ground, which are all neat approaches as well. So I don't see one solution for everything, but if we do as much as we can make great strides.
Thank you.
I do actually have one question. Do you see any best practices locally here that people can check out or people can see when they're walking through town?
Best practices or anything in particular, or for?
It's a good question, but just I guess for designing for building deconstruction or reusing structures.
Yeah, no, so the problem with all of, not the problem, the challenge with all of this is it takes more thought in the beginning. And a lot of times if you want this new science complex to go up, you want it to go up fast. So there hasn't been a lot of time built into the beginning planning stages to really think about, okay, well, let's make sure that all of our steel connections are bolted. Maybe we don't want to lock in concrete on metal deck because that's going to be hard to deconstruct. So it's usually smaller projects with careful kind of thought out processes. I don't have like a good idea off the top of my head for one that comes to mind. Sorry, I wasn't prepared for this question, but
That's all right.
we're beginning to see this shift in how everybody's thinking about things, which is really neat. I think like another big one would just be like stadium. Like if we build this big stadium for an event, and I'm sorry, I'm not big into the sports world, but are we going to reuse it or can we deconstruct it and reuse those elements somewhere else? Because you don't want it to just sit vacant afterwards.
Great, thank you. All right, Juan.
All right, just to add to Nancy's statement, the last one I think is really interesting because I think we've seen more of that for it's called large event planning. So if you think of the World Cup, you think of um, the Olympics. I believe Rio and the last World Cup both thought ahead about how do we deconstruct some of these stadiums that were built. I believe Qatar actually had a whole plan of taking down the entire stadium because shipping containers and brought over somewhere else. So it's a great idea, and I think we can learn a lot from those efforts. So just to introduce myself, and yes, I'm going to do. Everybody who knows me knows what's coming. I'm the one, the only, one of a kind, one in a million. If you haven't figured it out, my name's Juan. So sorry, I have to be consistently corny. So I'm Juan Gil Figueroa. I'm the Associate Director of Portfolio and Work Management. I served as the senior project manager on the Whitehall project. So just here to talk a little bit about that, answer any questions, really talk about some of the efforts we had through deconstruction. Um, Whitehall, for everybody who's aware, been around, you probably saw it come down, was a unique building on our campus. What happened was after towards the end of summer of 2023, I was got one of our associate or one of our AVPs reached out to me and said, "Hey, Juan, I need you on a call." And we had found that there were some significant water infiltration issues in the building. The building was built in 1925. Northeastern acquired it in 1961. The issues that plagued the building were as a result of things that predated us taking over. A big part of it's painting the brick. Just I've told this to our entire department: don't paint brick. Brick breathes, and if you paint it, it stops breathing, so you trap a lot of the moisture inside. And that was a lot of causes. That plus other stuff that improved the situation internally, made a bad situation worse. So we went through by reviewing the building as a whole, started the process of one, making sure that everything was safe. We eventually deemed that we needed to not occupy it that year, and moving forward with what do we do next, right? It was not something we had planned for, something that came up. We had to react. I just highlight that it wasn't just me. It took our entire department and a lot of people working a lot of time to make sure one, everybody was safe. Two, we were getting decisions made. We had to move the daycare center that was in the building. We had to move students out, relocate. We had student fairs. A whole lot of partners worked to get it done, initial as well as get as much information as we could to get decisions made moving forward. The whole building as a whole, that's 89,000 square feet, that which is a lot, and that accounts for about 429 student beds. So relocating 429 students was not easy, especially when we're talking about the end of the summer and we're nearing people moving back in. So I know student affairs had a lot to do with it, and I couldn't have done what they did. So, but from the very beginning, as we started talking to the city, we knew that deconstruction is something the city's pushing, and that was something that we should be doing as a whole. I had just come off an interior renovation of West Village G, where we had been able to salvage over about 100 refrigerators and donate them to a local nonprofit who makes them available to the community at a reduced cost, which was something fresh in my mind about how do we donate, reuse. And the great part of that program is we also had an agreement that if anything wasn't working, the university would take back and dispose of it properly to make sure we weren't putting that burden onto the community. Um, at first, I wasn't sure what 5-year-old refrigerators would really help people, but our partners highlighted the fact that if you're somebody of low income, or a refrigerator is not something you necessarily planned for, so having to get a new refrigerator halfway through is a big cost and can lead to a lot of debt. So having a place to go for them to be able to pick something up that will tide them over till they can get that money in place pulls a big burden off them. Plus, just because it's past our life of use, it doesn't mean it's past its own life. So it still has some good time to get people some to the next step. So that was a huge part of it. So as we started to look at the building, we did look at full deconstruction of it. But but Nancy just mentioned that one of the big things is stability and durability of materials is huge. With water infiltration being the main issue in the building, where brick and wood, which is what the building was mostly made out of, it's masonry and mass, which means that the exterior brick was actually the structural system, and timber was how it was all spread across. Nancy could probably say that a little bit better, but as because those systems have been wet and they're not meant to stay wet, they were undermined. So we didn't feel comfortable trying to reuse them in that sense. So true deconstruction wasn't available, but there was a whole lot of stuff that we could salvage. We started planning for this from day one, which was August 2023, and we were able to, some of the big things, all of the furniture in the building. It's over 250 setups of beds, desks, etc., chairs were all salvaged from the building. They were actually trucked over to Oakland because we were about to buy some new ones, and we were able to reuse them there. We did do the due diligence to figure out are we spending more resources to do this than to not? And we came down that it was still a good value. It saved the university some money, plus it let us not take on more additional resources. We we were able to donate 100 light fixtures to the same nonprofit that we worked with at West Village G. They then are able to sell it to the community back to be able to be reused. 200 plus window shades. We had we had three kitchens worth of appliances that we were able to donate that were relatively new, and we were able to also reuse all the common room furniture that had just been added into the building, which was really good. We had some exterior lighting we were able to salvage that had just recently been added. And lastly, we had 250 lock sets. So if you know the Seaboard tap lock sets, you see them throughout our campus that we were able to salvage. The big thing there is, not only was it the right thing to do, those lock sets run for about $2,500 a piece, and they're anywhere between 10 and 20 weeks lead time. So those, that's over $600,000 worth of savings for the university. Not to mention, when something goes down, we now have some stock to pull from to be able to salvage. This is all took over a year to plan out as we worked through it. We were also able to salvage some of the switch gear, which is the actual electrical equipment, the main electrical room equipment. Those things can take a very long time to get back. So parts and pieces were all salvaged. As we worked through, we worked with a bunch of partners to really facilitate the full planning. As I think everybody saw mostly, there was bridging, which is what we call the scaffolding around the building for some time, and then you start to see the windows removal. That was another big part why we couldn't salvage a lot of is, as Nancy mentioned, decontamination, right? In 1925, asbestos, lead, things like that were much more ubiquitous in use, and some of those things leach into their surroundings. So we had to remove those materials before we could even deconstruct or actually demolish the building, right? Because we were past the point of deconstruction. So that was a big part. The full planning process took about a year, and that was with all the approvals from the city. The actual start of demolishing the building started on October 21st, and I think a lot of our campus community was there. I remember sitting there and watching 30 or so people across the street just gawking. I was there taking photos because I too loved watching it. And it took only about 2 weeks to take the building down itself. And I think everybody as of last week, we were able to finally open back Forsyth Street. And a lot of that was the building coming down is what everybody thinks of when they think of demolition, but resetting the site, making sure that we put the correct fill, making sure that everything's back in place, all the sidewalks. That takes a little bit more time, but that was really the experience at Whitehall. Just to highlight, I think a big part of this and talking about how deconstruction and sustainability come about is from day one. I was working with both Jacob and Tori, who's on the call, to say, what can we do? We were working with our partners at Turner Construction, who was a construction manager, to push to see what we could do. We were reaching out to, at the first walkthrough, because we bid it out, we had teams of from companies that did donations and sort of worked with reuse walk through. So from day one, we were always planning on how are we going to do this. We were trying to track as much as we could. And it was a little bit atypical in the way that you want to do it fast, especially because it's an emergency, but we want it to be very specific. So to Nancy's point, the planning of it was so integral, not to mention the legal and all that stuff. So it really is one of those things that you have to start at the beginning. You have to be collaborative, and you have to sort of pull from what others have done. I think we learned a lot from lessons from Simmons College, who had done something similar not so long ago, as well as asking our community about what else were their thoughts and trying to pull. We have a huge set of information at the university. So how can we all work together to get more and to do what the right thing is? And to Nancy's point, once again, cost is huge, right? We didn't want to spend a whole lot of money because it's students' money. We want to make sure we do it cost effective. So it's hard to sell something that's a little bit more impactful, but we could look at it and say, it might cost us a little bit here, but here are the savings that it comes down to. And here's the benefit that we had. So overall, I don't think that any of the deconstruction efforts that we took on actually added cost to the project. And they absolutely added value for the university. So I know I didn't have a presentation, but any questions about Whitehall or Nancy, any thoughts?
No, I think that was great. I was definitely one of the ones gawking out there as well. Just impressed with how well everything came down. And my favorite part was how, to protect the street when they were demoing some of the brick, they hung these big giant
Yeah.
steel plates. Like I did end up taking a picture one of those days. I
So
think it
yeah,
gets,
that is 100% one of my favorite.
yeah,
So that's actually a
that guy there.
that's a 30,000 pound steel plate system that was custom made by the demo company, that they use to make sure that if something were to release off the building, it doesn't go into the street or hit any of the adjacencies. So yeah, it's an incredible system, and it took a lot of coordination to just make sure that it was there and that it wasn't in the way.
Did
So
we
I think
reuse that?
Karen's
Did
that is
Select Demo reuse that steel plate
yeah. So
master craftsman stuff?
yeah, that is their own system that they reuse. Select Demo was the subcontractor on the demolition. They do a lot of demolition around the city. And honestly, they were great partners, not only just in the planning and working through, but also the president of their company was on site for the 2 weeks of demolition every day, fielding and making sure, because the proximity of that site to our neighbors was huge. I know that we have apartment buildings that are leased partially by the university to house some students, also have their own apartments there. So we want to make sure that we could take the building down without putting anybody's life in danger, right? We also have the playground that's adjacent that we wanted to reuse, and we are going to be reused, that needed to be protected. So there's a lot of planning and careful coordination that had to go into it to talk about what do we have to do to make sure that we can protect the community, protect assets around, and that we're minimally impacting the people around us, which is easier said than done. Any other questions?
Yeah, my question was largely about embodied carbon avoidance calculation. Like, if there is there a figure that gets factored into that to compare against a complete demolition, just like a normal demolition would be in terms of protecting and stuff like that, protecting the surrounding areas. What is that financial kind of consideration? I know it is the right thing to do. I'm glad that we did it, but how do we justify that in terms of cost, in terms of calculating uh, how many metric tons of carbon do we save reclaiming kitchen equipment, reclaiming 8400s, which is technology, which is, all these other furniture, fixtures, equipment, all that stuff has intrinsic embodied carbon, right? I know that that's like a big study, life cycle cost analysis, but it would be interesting to kind of see and evaluate, okay, how much money did we actually save, comparatively?
So as far as a formal calculation, to be honest, there wasn't one that I could find. Maybe Nancy knows of one, but we did a lot of work. I know Jacob reached out to industry groups that he works with who are partners, do something. I think Tori did the same. We were trying to figure out how have others done it. What we were looking at specifically was, because we were also moving so quickly, was we did track relative weight, because that is how the industry has sort of been tracking it. So the weight of the furniture, how many pieces of furniture, what is the relative weight there? So that gives you somewhat of an idea of how much is not going into a landfill. I'm sure there's a better way, and if it wasn't an emergency sort of project, it's there. But I would love to hear what other people have done. Nancy, any thoughts on that?
I know, at least on the structural side and for other products as well, we have what we call EPDs, Environmental Product Declarations. So similar to a cost analysis where you'd want to tally up quantities of bricks or refrigerators or steel beams, whatever you have that can be reused, we can use a metric to kind of equate not only how much it would cost in terms of dollars, but also in carbon. So a lot of that is still being developed and improved, but that does weigh in even for new designs, if we're trying to decide if we're designing a building in steel or building in timber or building in concrete, not only how much is it going to cost in terms of dollars, but also again, a carbon equivalent. So same kind of thing where we're tallying up the quantities and then using this metric to help decide or kind of make our decisions for us. So I had like a little blurb on it on one of the slides. Essentially, it looks very similar to a nutrition label, let's say on a pack of cookies or whatever. So similar to that, you can kind of help guide your decisions. Okay, is this worth salvaging? Is it worth reusing when we're thinking about what we're doing in terms of trying to save pieces? So again, takes more effort, more thinking, more planning, but it can help show that this process is worth it.
So I think that there's a question in the chat from Nate Comte. It says an apartment building going up across the street from mine in Nubian Square. Ground up the demolished building material and concrete used at the base of a new building, as Nancy mentioned, is very cool to watch. And there's beyond the refrigerators and lighting, where other electrical and mechanical systems retained, reused, or saved, such as HVAC, etc. So that's part of the second part. And actually part of the first part, we left the caissons, which are the actual structural system, in place. When that site gets developed, they will rethink whether they can use the existing caissons or whether they'll have to be removed. For example, Marino sits on a former site that did reuse the existing caissons, so the structural system could be used. It'll depend on what goes back there. I'm not part of that, but talking about the other systems, we did look at mechanical systems and HVAC. We pulled parts if as it needed. The whole systems were a little older than what would have made sense for us to reuse. So all the metals too that were pulled from it get salvaged as part of the demo contractor's contract. There's value to those metals, from a recycling perspective. So they own the rights to those if we don't want them. So I'm sure those actually went into a recycling process because metal costs money. But I think the big part of those systems is the switchgear, right? So switchgear is what all of your main electrical connections go into in a building. Switchgear is the room the room they're housed in is the room I'm scared of because I'm not an electrician and that's a lot of power. And so getting switchgear takes forever. Over the last 5 years, switchgear, especially right after the pandemic, has been a very long lead time. It's caused a year or two of planning. You're thinking ahead. So when that switchgear was relatively new, we were able to salvage that, and it's actually it was planned to be reused at one of our on-campus projects. I'm not sure if it was, but I do know that the parts are things that aren't easy to get. So we've been using those for salvaging there. And the only other thing for electrical systems is we did reuse. There was an underground electrical lighting system that was put in place that we were able to salvage too because it was relatively new and we could use it somewhere else on campus.
Yeah, and thanks, Juan. And that building didn't have AC, right? So there wasn't extensive HVAC systems in there.
Yeah, there wasn't a fully.
Yeah. So, some of our dorms, older dorms don't have AC at all. There was a question from in the chat from Melody, getting at some of the new ideas that you're talking about, Nancy, around building design and materials, how they've been incorporated, I guess, in Northeastern projects. And Juan, do you want to take? I can answer that too, but you want to?
Yeah, I can. As far as the new building that will go on at White, that's very early on. That I don't know. I do know that we salvaged the wrought iron fencing for potential reuse in the future because it's the one piece that was very iconic to the building. So that was there. Reusing, and as we've been planning forward, our capital projects group is constantly looking at these things. I know that a lot of the lessons that were learned on White, we're planning for the arena in that project. I've sat in on meetings about what are we doing, how are we doing, and how are we planning for it. They are actively taking on a lot of the information we're being shared here and planning for it and seeing how do we make this a little bit more intentional. But I think, as Nancy has alluded to it, it's a relatively new concept that hasn't been utilized a lot. And I think Nancy's point of it takes so much planning that's what I think that's the apprehension a lot in the industry has been. People are always hesitant because it means a little bit, it can mean more work, and that's tough, right, to sell. But I know that there are a lot of efforts in the new arena about how do we reuse a lot of the components. Jacob, anything you want to add?
Yeah, I think I mean, these are new ideas. I think some of our designers who we work with are trying to incorporate them. So I think this discussion here is really trying to help us enter these ideas and concepts into our building projects. Because I mean, it's been hard enough to try to bring in these new ideas for net zero and operational carbon. But I think our new buildings are really addressing the embodied carbon side, but these kind of newer concepts of incorporating deconstruction into the design, it's just they're new, as Nancy was saying. So, but that's why we're having these discussions. Tori.
Thanks. Yeah, just want to say quickly, I mean, Juan, you mentioned you're able to do all of this basically without adding costs or time under a constrained timeline for actually bringing this building down safely. But I think we all recognize between you and Jacob, you put in a lot of your own time and effort. And awesome to hear that this is, actually informed another project, because I think there's a lot of for new things like this, there can be a lot of upfront time just to figure them out and then figure out how to incorporate them in your process. So really appreciate the work you all have done to get us there, that first step.
Yeah, though I mean, it's everything we do is we try as much as we can to be collaborative. And as much as it took some time, that's a challenge, right? And I think is at one point you were talking about the problem versus challenge. That's literally how I phrased it. I'm like, it's not a problem, it's a challenge. How do we do it? What can we do? And as a project manager, it's our job to sort of consistently weigh that, right? And it's how do we go? How do we get the time and how do we put the effort in? And there is a certain point where you're like, I want to really do this, but we have to go to the other side. We have to divert. We have to make a decision on this. But as long as we have the time, there is no. I'm not going for easy. I mean, easy. I wouldn't stay where I'm doing what I'm doing. That's not what excites me. The challenges are what excites me. That's what's fun. That's what makes our job fun. Is that every day is different. Every project is different. So trying to do a little bit better is what drives me. I think Nate had a question.
Yeah,
I see one about,
Nate, do you want to come on and ask it, or we can ask it for you?
Sure, yeah. I was just wondering if students were involved, like civil engineering students or others were involved in these projects at all. It seems like it could be a really good learning opportunity.
So we do have co-ops. We didn't have it specifically on White. It was moved so fast. It's tough to get integrated. But I do know that there was a few different classes that brought their students out to watch the demo process, and I believe there were some assignments related to it. We do try to share as much as we can. We have co-ops as part of our program. often we have classes reach out about being part of the process and coming in and seeing some of the work we're doing. So as often as we can, we try to integrate. It's a little difficult from the perspective of there's a liability issue when there's construction going on. The sites don't technically they belong to the university, but they're not under our control. They're under the construction manager's liability. So we have to make sure we have to ask permission for them to enter. So when we can and when we can do it safely, we try because that's what we're about, right? Experiential learning is about getting hands on, seeing what's going on, and being part of it. So whenever we can, we try to make it happen.
That's awesome. And then one other question, a little bit in a different vein. I don't know, maybe that you don't know quite yet, but for Matthews Arena being, a historical landmark and, one of the oldest athletic facilities still in use, what are the plans or like, can you give any insight into what's going to be saved? Like, is the facade going to remain or like what components are targeting like reuse or remaining in place versus demolition?
So I'm not part of the arena project. I know that there's a lot of things that they've been talking about as more for salvaging, trying to reuse in that sense. Jacob, do you have any more insight in there?
Yeah, they're gonna reuse. They're gonna keep the arch on the main entrance, and have it as an architectural feature. They're really looking ways to reuse the beams, the roof beams, and to integrate them into the ceiling of the arena to kind of hold that feel in there. But that building is in rough shape, which is why they have to demolish it and move on. So there really isn't a lot of opportunity to reuse materials, especially on the structural side. They will be reusing caissons in the ground, but they're I'm trying to. It's a fascinating project on many levels, but the schedule for demo is insanely tight, and so they really only have like 3 weeks to remove the interior materials, non-structural materials, between when the last game is and everything's closed down to when they're going to start knocking it down. So we are working on trying to maximize that as much as possible right now. So hopefully we'll have more to talk about that
Excited to
this
see.
summer.
Awesome. Yeah, excited to see how that goes along.
Yeah, and well, this summer on the non-deconstruction side, they're going to start drilling the geothermal wells on the parking lot next to the arena.
Great.
Yeah.
Yeah,
What
one
kind
of-
of also, there may be more, this might come up, but sustainability features will go into the building beyond just like the reclaiming or any new buildings. So like, is the school looking in like energy efficiency measures
Yes,
or cool roof
absolutely.
technology or things of that nature?
Yeah, actually, I hosted a panel of the project teams on that building and all the sustainability aspects for that. So I'll be we take up a whole panel just talking about that. So I'll make sure to share that with everybody. But we're doing geothermal, solar. It's gonna be all electric building. It's lots of heat recovery. It's gonna be really interesting.
Awesome. Yeah, really glad to hear that.
Thank you, Nate. Any more
Mark
questions?
jumped on. I see him. Mark, do you have anything that we missed on the arena? Because I know he has a little bit more insight.
No, I would add to what Jacob said, just say basically there was a great article, right, that was put out, was it Northeast News put it out, and that gives you some photos, or I should say renderings of what we plan on doing with the arch and
Yes.
stuff like that.
Thank
that
you.
can see. Yeah.
Oh, that's a great idea.
Yeah.
Yeah, one struggle to just reusing the roof trusses, for example, is if you were to analyze that building with today's codes that we'd have to design for, it not quite strong enough, like just with wind and changes to seismic and everything. So anything we're doing new, we're essentially building it more robust. And it's definitely stood the test of time, but we'd have to make some changes to any sort of new structure, even if we're reusing existing pieces.
Were there any other questions? See any? don't think so. Here, none. So I want to thank Nancy. Thank you for sharing that information on it. I think so much of the, the designing for deconstruction is something that is really interesting because it's not something that I'm aware of. You said, you jokingly said I'm not an architect. I was an architect by training, not by licensure. Sure. So, but I think I've always found it beautiful in reuse. I think of you go down to the seaport, what used to be Russian Wharf, which is in front of the Federal Reserve. And we do this a lot in Boston. They've reused the exterior facade and the detailed elements there and it gives building character, right? So I think
Mhm.
we don't do it enough in the US, but you see it a lot in Europe where they marry new with old and sort of herald both sides. The benefits of modern construction with the beauty of and details associated with artisan craftsmanship that honestly just it's not cost effective nowadays.
No, it is amazing. When you first said seaport, I'm like glass boxes? No, no, you get the old character.
Right before the seaport, technically.
Yeah.
All right. Well, thank you very much, Juan and Nancy. Really appreciate you guys coming on. Coming on here and giving an overview of this ideas, and I look forward to working with both of you in the future. And anybody else on the call, please reach out and enjoy the rest of Sustainability Innovation Week. All right. Any last thoughts? Great.
Thank you, Jacob.
All right. Thank you, everyone. Thank you for joining us.
Thank
Have a
you.
good one.
Bye.